Ngalakin Khadijan Nyunga Boja.
Video 9. In this video, we're going to take a deeper look into the select statement. You've all seen roughly how the select statement works from the first labs, but some of the things that occurred may have surprised you, and you may have wondered why certain things happened or other things didn't happen as you expected. So by understanding more precisely exactly how select works, that means we will be less surprised and more likely to be able to write the queries that we actually want. Okay, the select statement has many parts, but the basic structure is all to do with the three keywords: select, and that's going to choose which columns are to be returned by the query; from, and the from part constructs an initial table which is then passed to the where clause, and the where clause selects the rows that are to be passed to the selection. So even though that's sort of the different order from how they are written in the command, what really happens is that the from statement is first executed. That produces some table as its output. The table is then passed to the where clause, and the where clause will select some of the rows of the table and delete others or forget about others. So that resulting table is then passed into the select clause, and the select clause just prints out or returns to the screen the rows, the columns that are named in the select statement. Okay, so even though it's stated select from where, the actual operation, logically speaking, is more like from happens first, where happens next, and select happens last. Okay, so let's return to the little database that we did in the last lecture. We've got students, enrollments, and units. And what I want to do is make a list of names of this year's CITS1402 students. So what I want to do is find all the students that are taking CITS1402 in 2020 and write down their names on the screen. Okay, the marks database has these three tables: student, enrollment, unit. Which tables am I going to have to use in order to answer this question? Well, I need names. So that means I can only find names in the student table. I need to be able to tell which students are doing CITS1402. Well, CITS1402 is a unit code. Unit code is either in the enrollment or the unit table, but in fact, I don't need the unit table, because that's just got the only extra information that has is the name of the unit. I don't actually need the name of the unit. So the only tables that I need are student and enrollment. Okay, so that was the first step of a plan. And this is sort of the general procedure that you should take whenever you're devising a query for anything. So first of all, figure out which tables you actually need to use at some stage in your query. Okay, so I have to use student and I have to use enrollment. I can get away without using unit, and so in the interest of simplicity, I will get away without using unit. Then I'm going to have to join the tables. And how am I going to join student and enrollment? Well, they're going to have to be joined on the student number, because the student number uniquely identifies a particular student, and the student number in the enrollment table identifies all of the different units that that student has ever taken. So the tables will be joined based on student number. Then I will have a list of all students and all of the units that they have taken, but I'm not interested in those. I'm only interested in the ones for CITS1402 and the ones in 2020. So I keep only the rows that are relevant to CITS1402 students in 2020. And then finally, I will just ask for the names of those students, and that will print out exactly the required information. Okay, so I want to introduce a different way of joining tables. So last week we looked at a particular join where we used a strange operator, which was just called comma. And so student comma enrollment would then form the full Cartesian product of the student table and the enrollment table. So it would line up every single student with every single enrollment in all possible ways. But of course, most of those are irrelevant, because if the first half of the tuple, the student half of the tuple, refers to one student and the enrollment half of the tuple refers to another student, then it's junk. It's not giving us any useful information. So we had to use a where clause in order to throw out all of the junk and only keep the relevant information. In this case, the where clause is going to say that the SNUM field, the student number field from the table student, is equal to the student number field from the table enrollment. We had to use the full name of these columns, like student.snum, enrollment.snum, because we can't put where snum equals snum, because it doesn't know which snum it's referring to. Now I want to just rewrite this in another way. So instead of using a from and a where, I'm going to use this construction. From student join enrollment. So join is a keyword, and that means we're about to do a join, and I'm going to tell you how to join the two tables together. And the join is going to be done on the condition student.snum equals enrollment.snum. Okay, why do I want to express the join in this way instead of the other way when they all look pretty much the same? Well, the reason is that I really want to highlight that this part of the construction is how the initial table is built in order to be further processed. So this is sort of the initial table. Okay, and then the where conditions are going to be applied later. So this is this sort of separates the conditions into the ones doing the join and the ones doing selections of the rows later. And I want to be very clear about exactly what part of the SQL statement is doing what particular thing. Okay. So let's just see what we would get if we just look at this table. So I'm just sort of going to look at it first, and then we'll see how it's going to be subsequently processed by the application of the where conditions and the from conditions. Now I'm going to also slip in some additional information about working with SQLite. So I'm going to turn the headers on so I get the names of the columns at the beginning of any output. I'm going to ask it to do mode column. So it's going to put each field into a separate column instead of just putting that vertical bar in between them. And then I'm going to say I want my columns to have width 8 characters for the first one, 8 characters for the second, 8 characters for the third, and so on. So all of these things are just SQLite special things, and they just sort of dress up the output a bit. So fancy output is all I'm going to say there. It's not part of SQL. It's just part of using the SQLite prompt just to make things more just to make things look more like tables, so I can illustrate various things. Okay, so the table that we have produced is one obtained from student join enrollment, so that's a full Cartesian product, every possible array of three things, a 3-tuple from student and a 4-tuple from enrollment. Then I have forced them to only have the student number snum match up with the enrollment snum. Okay, so what does this do? Well, this tuple, the emails are still null, by the way. So, so this tuple, 1 Amy null, was from the student table. This tuple, 1 math 1001 2018 55, that was a tuple from the enrollment table. At some stage, a big tuple obtained by sort of just gluing those two together would have been formed, and then we only kept the ones that satisfied the condition snum equals snum. The student snum equals the enrollment snum. Okay, why do we do that? Well, because now this row contains complete information about one attempt by Amy at 1 unit in 1 year. So this row has now sort of joined back the information that's in students and enrollment in such a way that we have a row telling us the combined information from both of those tables. Okay, and similarly, so at the moment we've just got Amy has done things twice. She's done 2 units and passed them both. Bill has taken CITS1402 once and is now repeating it, but it's not finished yet, so we don't know what Bill's mark is. Okay, so this then is the initial table where everything else so in here, after the from statement, this is a description of a table. Description of a table. Now, the description of a table can either be just the name of a table, if you're just selecting stuff from one table, or it can be a join condition, or it can be a fancier thing that we won't look at until later. Okay. Now we're going to fill in the bits that I've missed out, the select bit and the where bit. How I want you to think of these is the where command slices out rows. The select command slices out columns. Okay, don't worry about that right now. It'll all become clear by the end of this lecture. Okay, so after the where clause then, there should be a Boolean expression which can use any of the following things. The columns of the source table, in other words, the names of the columns, they're variables. They'll be given a particular value at when each row is processed. Okay, when I say the source table, I mean the initial table that was constructed by the from statement. So from. So you build up a Boolean expression that will involve the names of the columns. It might involve arithmetic operators and functions. It might involve constant values, which are like just numbers or strings or whatever. So a Boolean expression is an expression that evaluates to either true or false. So now we will have to look carefully at Booleans later, but it's basically a logical statement that evaluates to true or false. Here are some examples of Boolean statements that we may have encountered earlier. So, like home score, this is from the AFL case, home score equals 100. Okay, that is a Boolean expression. It checks whether the home score is equal to 100. If it's processing a row where the home team scored exactly 100 points, then that will be true. If it's processing a row where the home team did not score 100 points, then that will be false. And whether the where expression, whether that is true or false, determines whether we keep the row or delete the row. So this is a column. This is a logical operator. And this is a constant value. And we saw in the AFL lab that you can make your, that the where condition can be made quite complicated by combining expressions with and or by using inbuilt functions from SQLite and so on. For the time being though, all we need to know is that whatever expression you put there is evaluated for every row of the source table, the one that was just being constructed by from, and only the rows where the expression is true are kept. So if the expression is false, it's just filtered out. It doesn't go any further in this process. Okay, so for this example from the marks, which rows do I want to keep? Well, I only want to keep the rows where two things happen. I want the unit code to be CITS1402, and I want the year to be 2020. And the and is a Boolean operator that says that both of these things must be true. Okay, so now let me add that condition into the, so you see I'm sort of building up the statement from the inside out. Let me now add that condition. And so where has to be there. And now you have to have some Boolean expression. Ucode equals CITS1402 and year equals 2020. You can use brackets in the normal way to ensure that you get your precedence correct. So you might want to write where Ucode equals CITS1402 and brackets year equals 2020. And that just guarantees you that the phrase that you've just written will be parsed in the correct way. It'll check this first and then get a true or false value. It'll check this next and get a true or false value. And then it will evaluate and decide whether both of those things are true or not. Okay, so now we have only one row left. The source table had 4 rows, all of Amy's enrollments, all of Bill's enrollments. After we've used the where condition, 3 of them have dropped out. 2 of them because they weren't CITS1402, and 1 of them because the year wasn't 2020. So just 1 row has survived. So here's sort of the process. The where statement is here. This table comes from the from statement. So that was the joint. When I say this table, I mean this table. So I like to think of it as these rows all dropping down, like imagine them sailing down the screen. Then you've got the where clause here. And the where clause is like a sieve or a filter. It only allows through the rows that pass the condition. Okay, well, there was 4 rows that went in. These 2 rows failed the condition because the unit was incorrect. This one failed the condition because the year was incorrect. And so it's only the final row that survives. So 2, Bill, null, 2, Bill, null, 2, CITS1402, 2020, null. Okay, what did the specification ask for? The specification asked for the names of the students who are taking CITS1402 in 2020, and that's where the select part of the statement comes from. So all I'm asking it to do is select S name. Okay, so let's analyze the parts of this query. This is the source table. So SQL constructs that first. Then it passes it through the filter. The where clause is the filter. It will delete some rows or not pass through some rows. Finally, it goes into the select area, and then that will only keep the values that are named there. Okay, so the full statement then is select sname from student join enrollment on student.snum equals enrollment.snum, where ucode equals CITS1402 and year is 2020. The answer, the only person in the database who's taking this unit is Bill. Okay, so the way to think about projection, the way to think about selection is that it is an operator that performs the mathematical operation of projection. What projection is when you take in a vector and you only keep some of the components of the vector. So the select, so this table, this 7-column table came in, but we were asking to project onto the sname field. And that just means that we forget about all the fields that aren't sname, and we only keep the one that has been asked for. So that corresponds to projection or a deletion of columns. Overall then, what select does is it slices the table horizontally, dices it vertically, and then produces the output. So from constructs an initial table, where does some horizontal slicing, completely removing some rows. Select does some vertical slicing, completely removing some columns. And whatever is left after that is the output table. If you do this in the SQLite prompt, then the output table is simply reproduced on the screen. It's simply printed onto the screen. But the key thing to remember, though, is that it is still a table. And so you can do with it anything else that you can do with a table. Okay, all of the other things that select does are sort of elaborations, additional fanciness to that basic operation. Okay, I'll just look at a couple of them now, and later we'll see lots more. If you want to keep more than one column, well, just name all the columns you want, separated by commas. Now, I'm going to ask for the student number and the student name. Okay. Okay, now there is a slight problem here, though, because when I run that, I see I've asked for sname, but unfortunately, I've asked for snum and sname, but unfortunately, snum appears in both tables, student and enrollment. So snum is still there. So the table that's passed in has got two columns called snum. In order to avoid that, well, if I try to do this, I will get error, ambiguous column name snum, because there are two snums. And so in order to avoid that, then I just have to give the full name of the snum column that I want. So I'm just going to say I want student.snum. Now, in this case, student.snum and enrollment.snum are the same, but SQL doesn't know that. So I actually have to tell it. So now if I put this enhanced select statement in, then I get an output table that has two columns called snum and sname, and the values are to and Bill. Yeah, so often you might want a class list that contains names, but usually you want a class list that contains student numbers and student names. Second fanciness that we can do is we can rename the columns in the final table if we want them to have different names for some reason. And this is obtained by just adding the as statement, as number. as name. So what this means is everything else is the same. It constructs the initial table the same. It does the selection the same. It does the dicing of the rows the same. It does the selection of the same two columns, student.snum and sname, but then it just gives them, then it renames the columns. So the output table then now has columns which are called number and name, even though the input table had columns called snum and sname and so on. Okay, why on earth would we want to rename the columns? Well, if you're just looking at the output on the screen, you don't really care what the columns are called. But the whole point is that it's all tables. The output of the SQL query is a table. And that means that you can use that SQL query wherever a table is required. So that means that you could have another query where instead of putting the name of a table, you can just use a SQL query that constructs a table. So a SQL query can contain, as one of its components, can contain another SQL query. And so the table doesn't have to be constructed and then saved somewhere to be reused. You can actually just write a SQL query that refers to another SQL query. Okay, I don't think I explained that very well, and we'll see it more later. So don't let this slide worry you for now. Okay, we'll do this better later. I'm sort of just trying to give you a little forward glimpse into why we might want to be able to rename the columns of a table. Okay, if you look at Help 1402, you will see lots of questions from people who say, why is this happening? And they will put their command down, and the command will sort of look, sensible, but it won't do what they wanted it to do. And the trouble is always that SQL does exactly as you tell it to do. So often what you tell it to do is not what you want it to do because you didn't really know how to tell it precisely. So in order to debug a SQL query when you get some errors or unexpected things, you really have to put yourself into the mindset of the row processing machine. So you look at the query that you have written and then ask the following three questions. What is the initial table constructed by the from clause? Has that been done correctly? If the initial table is wrong, then everything's going to be wrong. Then look at the where condition and ask yourself, is this discarding and keeping the correct rows? Does the where condition reflect the things that I wanted to keep? And then finally, if you've built the right table and you've kept the right rows, but your output is still not what you expected, then ask, has my select statement chosen the right columns to produce for the output table? Okay, so really sort of go back and methodically think about how would the computer perform these operations. Just by doing this, you will find that you'll be able to debug probably 90% of your non-working SQL queries. There are, of course, additional complications. There are more complicated more complicated select statements, and there are some idiosyncrasies where SQL implementations differ from each other, and there are some just plain strange syntax decisions that were made by the SQL standards body. So there are some things that you will encounter that will be mysterious and you can't really figure out why, but most of the problems you encounter will be caused by some logical error in these 3 steps. Okay, well that's that for the select operator, and I shall stop the recording